Hello friends. Welcome to T Academy. In this video, I am going to share few important points for electrical engineering for any competitive examinations. The very important point or topic here it is, that is resonance. So resonance is the important topic which comes in each and every examinations. Okay, and that too some theory questions are there. The questions are very standard questions, right? So, without discussing the detailed explanation, I am going to give some basic formulas or basic concepts about the resonance which will be useful for your examinations. I can assure that at least 1 mark question will be present in your examination regarding if you cover this topic. Okay, and I will share this important formulas regarding this topic here. So first, resonance, there are two types of resonance. First one is a series resonance, second one is a parallel resonance. Okay, so first series resonance we'll talk about. In series resonance there are resistance, inductance and capacitance. We can call this R, L and C elements, right? When we connect it to the AC supply here, okay, at a particular frequency, okay, the reactive nature of this series RL circuit will be 0. Okay, simply it is nothing but resonance. So Z is equal to R plus J XL minus XC. Okay, where XL is the inductive reactance, XC is the capacitive reactance, and you know that R is a resistance here. At resonance condition, as I told you earlier, XL is equal to XC means the inductive and capacitive reactance are both are equal in magnitude, but they are 180 degrees out of phase here. Okay, and you should keep this point in your mind. At resonance condition, either it may be series or it may be a parallel, it the impedance is nothing but here Z. That is nothing but R. Okay, that is UPF, that means unity power factor. So this is a very important point here. Okay, most of the cases in the examination they will ask this point only. Okay, in a series RLC circuit at resonance condition the power factor will be, the options are 0.707, 1, okay, 0, or any of the above, like that they will ask questions, right? But at resonance condition it is a unity power factor. Especially in case of series resonance, the current I naught that is flowing in this circuits, okay, I naught will have a maximum value. Why? I will tell you. Because of minimum impedance. As I told you earlier, that impedance is equal to R plus J XL minus XC here. When XL is equal to XC, this entire term is going to be 0. Okay, so simply Z is equal to R only. When Z is equal to R, here see, observe, it is going to have a maximum amount of current here. Okay, now so here we'll talk about what about the voltages. Voltage across inductor is equal to voltage across capacitor, but they are out of phase. That means when you are talking about the inductor voltage, capacitor voltage, they are out of phase here. Okay, and what is the relationship between the inductive voltage and capacitive voltage is they are equal to Q times of Vs. What is a Q, sir? So Q is nothing but a quality factor. Okay, this is also important question, especially those are preparing for AE examinations, right? So quality factor, they will ask some relationship. I think I remember one of the AE examination they ask what is the relationship between quality factor and power factor. Okay, now what is the quality factor? So quality factor Q is equal to omega naught L divided by R. So simply I can say energy stored divided by energy dissipated. Okay, if you write in terms of capacitance 1 by omega naught RC. So in the next slide we are going to see that for parallel parallel resonance also, for parallel resonance also we'll see what is the formula for quality factor. So Q is equal to 1 by R into square root of L by C. So in this formula, in examinations point of view, they will mention RLC value, they will ask quality factor, or they may give quality factor, L value and R value, they will ask C value. So any 3 variables are given, 4th variable you have to calculate. Okay, next, bandwidth. So very important, bandwidth. Okay, so bandwidth is nothing but it is a difference between the upper cutoff frequency to lower cutoff frequency, which is nothing but R by L here. Okay, R by L. So I am not discussing the derivations of these formulas. Why? Because in competitive exams they won't ask derivations, right? Now, so see here. So this is the upper cutoff frequency. So here we can see W1 is the lower cutoff frequency, W2 is upper cutoff frequency, W0 is resonant frequency. Okay, I think I remember in the 2012 GENCO, AP GENCO, they asked this question here. Okay, they asked this question: what is the relationship between the upper cutoff frequency and lower cutoff frequency? Omega naught equal to square root of W1 W2 here. So W2 is nothing but this is equal to, okay, so W0 plus delta W by 2, W1 is equal to W0 minus delta W by 2 here. Okay, so sometimes they may combine this concept with the control systems concept. What is the zeta here? Zeta is nothing but damping ratio. Okay, so damping. So zeta is equal to 1 by 2 QL. So this also be remembered. They may ask like this. Okay, if the quality factor doubles, what about the zeta value? Like that they will ask questions. They can frame the questions here. Okay. Now next here, these formulas are important to be remembered. Okay, they won't ask questions based on this, the numerical questions, especially for the non-calculator examinations. But you have to remember this one because these options are directly present in the options. Okay, the frequency at which the voltage across inductor is maximum. So just now we discussed, we have R, L, C. Okay, now we know that VC is equal to Q times that of Vs. We studied that. Okay, so similarly V is equal to VL also. But the frequency at which, we need to find a frequency at which voltage across inductor is maximum. So here voltage across capacitor is maximum. Then you have to remember this formula here. That is 1 by 2 pi square root of LC minus C square R square by 2. Similarly, for capacitors, 1 by 2 pi square root of LC minus R square by 2L square here. Okay, and the next important questions here. Okay, selectivity. Selectivity is nothing but omega naught divided by omega 2 minus omega 1. So F naught by F2 minus F1 here. That's nothing but resonance frequency divided by bandwidth here. Okay, so what is the relationship between selectivity and quality factor? So these are the one of the examination question here. Okay, so selectivity increases, bandwidth decreases, quality factor increases. So I can say selectivity is proportional to quality factor. Okay, selectivity of series RL circuit, whether C with C or L as variable. Okay, so this is a question asked in the examination. Okay, so Q by 2. So they may ask a quality factor, they may give some quality factor value. Then one of the capacitance or inductance is variable. Then what is the selectivity? Like that they can ask. Okay, now this is also one of the question here. So series RL circuit act as a band pass filter. So series RLC circuit act as a band pass filter. Okay, now what are the points we discussed here, we studied, we learned here. So there are similar kind of explanation, but some terms are going to be opposite exactly. Okay, see what is this here. Parallel circuit. So parallel circuit, in a series circuit I talked about Z. We discussed about Z here, that is impedance. Now in a parallel circuit we will talk about the admittance. Y is equal to G plus J, BC minus BL. In series RL circuit, XL is equal to XC we discuss. Similarly here, BC is equal to BL. And in series resonance or parallel resonance, common thing is the circuit will operate at unity power factor. That is a cos theta is equal to 1. Okay. Now, in a series RLC circuit, the current I naught is what? It's a maximum value. But here it is a reverse case. Okay, keep this point. And Z max, it is in a series RL circuit, it's a minimum value and it's a maximum value. There it was a okay. So there it was minimum value. So the current is maximum as you can see here. So one point I forgot to remember here. So why it is called half power frequencies means the current flowing in this series RLC circuit is 1 by root 2. Suppose P is nothing but I square R we did now. So if you are doing like that, so I naught by 2 whole square means I naught square by 2. That means power will be at half. Okay. Now one point you should keep in mind here, from zero frequency to resonance frequency, the circuit behaved as a RC circuit. So this point should be keep in mind. From resonance frequency to upper cutoff frequency. Okay, upper cut-off frequency, the circuit behaves as a RL circuit. Similar case, in case of a parallel RLC circuit, it is a reverse case. From 0 frequency to that is a lower cut-off frequency to omega naught, that is a resonance frequency, the circuit behave as a RL, and here it is a RC circuit, just reverse of it. Okay, ulta. Next, in a series RL circuit, we discussed that VL is equal to VC, and here we are talking about IC is equal to IL, and they are 180 degrees out of phase here. Okay, there we studied VC is equal to VL equal to Q into Vs. Here IC is equal to IL is equal to Q into Is, right? So there is a in a series voltage, and here is a current. You should keep in mind. Now Q is equal to R by omega L. Okay, in a series RL circuit, we talk about omega L by R. Here it is reverse volta. There 1 by omega RC, here omega RC. There 1 by R square root of L by C, and here it is R into square root of C by L. Okay, so and this is the basic formula, resonance frequency by bandwidth. So act as a band reject filter. Okay, act as a band reject filter, and the bandwidth formula is 1 by RC, zeta is equal to 1 by 2Q here. Okay, so you can remember simple thing here. What is the time constants of RC network? Time constant is equal to RC. Okay, and the time constant is equal to L by R. So this is for capacitor. Okay, this is for capacitor and this is for inductor. So what is the bandwidth here? So bandwidth is inversely proportional to time constant, you can say, right? Okay, so for RC network, bandwidth is 1 by RC, and zeta is equal to 1 by 2Q here. So similarly, you can compare here and study. And here parallel resonance circuit here. So parallel resonance circuit we discussed already, but here in some practical cases, okay, if the examiner want to give the question paper little bit tough in this concept, then he may choose this topic here. Okay, so where we have parallel of combination of LC circuit with their internal resistances RL and RC here. Okay, and the current flowing here is a IC IL here. Okay, omega naught equal to 1 by square root of LC square root of RL square minus L by C divided by RC square minus L by C here. Okay, so we'll neglect the RC value here. So if RC value is neglected, then I can rewrite the circuit as F naught equal to, okay, 1 by 2 by square root of 1 by LC minus R square by L square. So you can RL square by L square here. That is equal to 1 by 2 by square root of LC into square root of 1 minus 1 by Q square here. Okay, the relationship between IC and IL is equal to 1 by square root of 1 minus 1 by Q square here. As the Q value increases, IL value, IC value increases, as we seen earlier. Okay, and one more point here, it is the difference between these currents, that is a capacitive current and inductive current, will be decreased as the quality factor increases. So these are the one of the competitive exam question they asked here. What is the quality factor of a parallel RL circuit increases? What about the current flowing in the inductor and capacitor? Okay, so both are increase, both decreases, increase, remain same. Okay, so both are going to be increase, but the difference between them is going to be remain very less value. Okay, now one more simplification here. The impedance at resonance Z0 is equal to RL into 1 plus Q square. Okay, impedance at resonance for this particular circuit here. Okay, which can also be written as L by RC, which is equal to RL plus Q into omega naught into L. If the RL value is also neglected, then Z0 is equal to omega naught into L into Q here, impedance. Okay, so this is equal to Q divided by omega naught into C. Okay, so that's it for this session, friends. If you like the video and if you want more videos, please subscribe to my channel and share with your friends. Please increase the views of these videos so that we are interested to do more for you. Thank you. Have a nice day.